The quotient rule for differentiation. Let f of x and g of x be differentiable functions with g of x not equal to 0. Then the derivative of f of x over g of x is defined as d dx f of x times g of x minus the product of f of x times d dx g of x, all divided by g of x quantity squared. The derivative of a quotient of two functions is the ratio of the quantity derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, all divided by the denominator squared. For me, that's a big mouthful, so I prefer to memorize it this way. That is, if I have a function y, and I'm going to have h over L as in high over low. And so if I want the derivative, I remember it as, we'll begin, low d high, that's the derivative of the high, minus high d low divided by L squared. That is low d high minus high d low over low squared. This is yet another differentiation formula that you need to memorize. Example 2.1.4. Use the quotient rule and the rules of exponents along with the power rule for differentiation to show that the derivative of a of x equals x squared and the derivative of b of x equals x to the fifth divided by x cubed are the same. So let's look at a of x equals x squared. That derivative, a prime of x, using the power rule for functions, we bring down the 2, still have x, and then 2 minus 1 is just 1, so we've got the derivative of a of x. Now let's look at b of x. To do b of x, okay, we have the x to the fifth over x cubed, but we want to use the quotient rule. And the quotient rule for y equals, let's see, we had high above and low in the bottom. Then the rule was, let's see, y prime is low d high minus high d low over low squared. So in this instance, we'll just match it up. The high function is x to the 5, the low function is x cubed, and let's apply that quotient rule. So b prime of x is equal to, I'll begin with the denominator so that I don't forget it. We've got x cubed squared. Now the low function is x cubed. Then we need to take the derivative of the high function. The high function is x to the 5, so we bring the 5 down, make it the coefficient. X to the power of 5 minus 1 is 4. Then minus, now we list the high function, which is x to the fifth, and the derivative of the low function is x cubed. We bring down the 3, then you got x squared. That doesn't look like 2x. Let's hope some algebraic simplification helps here. So we'll work across, and I've got 5 x cubed times x to the 4th. That'll be x to the 7th minus 3, and then x to the 5th times x squared is also x to the 7th, and the denominator x cubed squared is x to the 6th. Let's continue. So 5x to the 7th minus 2x to the 7th would be, minus 3x to the 7th would be 2x to the 7th divided by x to the 6th, and that changes or simplifies to 2x. It actually matches. Example 2.1.5, find the derivatives of the following functions, part A. F of x equals 1 minus 3x quantity divided by x squared plus 2 quantity. This is definitely a quotient rule problem, so we'll use the low d high minus high d low. We'll label the top part the high, bottom part the low. Then the derivative, y prime, again, let's list that, is going to be low d high minus high d low divided by the denominator squared. So we'll have f prime of x is equal to the low function, which is x squared plus 2. We need to multiply it to the derivative of 1 minus 3x. The derivative of 1 is 0. The derivative of negative 3x is negative 3. Then minus, we'll write the high function, which is 1 minus 3x. And we'll take the derivative of the low, which is x squared plus 2. The derivative of x squared is 2x. And the derivative of 2 is 0. This entire expression is divided by the low, that's x squared plus 2 squared. Now let's do some simplifying. I'll begin by distributing the negative 3 in the numerator. So let's see, negative 3 times x squared. Negative 3 times 2 would still just be a negative, but 6. And then for the second term, we need to distribute the 2x and the negative. So we'll have minus 2x. Negative and negative will give us a plus. 3 times 2 is 6. X times x is x squared. And the denominator is still x squared plus 2, quantity squared. Let's do one final cleanup, and we'll get that the derivative f prime of x is equal to, and the numerator, the negative 3x squared and the positive 6x squared has common terms, so we'll have a positive 3x squared minus 6 minus 2x, and the denominator will still be x squared plus 2 quantity squared. Part B, y equals 5 times e to the power of x squared divided by 3 times x to the 7th. This is a quotient rule property again, so I'm going to use my quotient rule. We'll label the top one high, so 5e to the x squared is going to be the h, and the 3x to the 7th will be the l, and the quotient rule for y equals h over l, and that's going to be low d high minus high d low over the low squared. Let's apply that. Y prime is equal to the low function, which is 3x to the 7th, times the derivative of 5e to the x squared. So the 5 stays put, that's a constant. And when you take the derivative of e to anything, the e to anything stays put, but you must also multiply it by the derivative of the power, and the derivative of x squared is 2x. Now let's do minus the high, which is the function 5e to the x squared, and the derivative of the low, that's 3x to the 7th. We bring down the 7, so 3 times 7 is 21x to the power of 7 minus 1 is 6. And that thing is all divided by 3x to the power of 7 squared. Let's clean that up a little bit. So we got y prime equals 3 times 5 is 15. 15 times 2 is 30. We have e x squared. Then we have x to the 7th and an x, so that'll be x to the 8th, minus, we have 5 times 21, that's 105. We still have e to the x squared, and then we still have the x to the 6th, And in the denominator, 3 squared is 9, and x to the 7 times 2 is 14. Okay, what common term can we factor out of the numerator? Well, in the numerator, the constant 15 is common. We also can factor out an x to the 6th and an e to the power of x squared. Let's see what remains. If I divide 30 by 15, that gives me a 2. The e to the x squareds cancel out, so that's 1. X to the 8th divided by x to the 6th would leave me an x squared. And for the second term, 105 divided by 15, that gives me 7. And then e to the x squared and x to the 6th were all factored out. And in the denominator, we still have 9x to the 14th. Oh, and that does simplify just a little bit more. So we can say that y prime is equal to 15 ninths. That'll reduce to 5 thirds. You have x to the 6th in the numerator, x to the 14 in the denominator, so that could give us x to the 8 in the denominator. We still have e to the power of x squared and the binomial 2x squared minus 7. Part C, y equals the quantity x squared minus 3x plus 2 divided by the quantity 7 minus x. So we'll have a high and a low. The quotient rule, if we have a high function and a low function, we write that that is equal to low d high minus high, d as in derivative, low divided by low squared. Let's take the derivative. Y prime is equal to the low function, I'll write 7 minus x. The derivative of x squared minus 3x plus 2. The derivative of x squared is 2x. The derivative of negative 3x is just negative 3. And the derivative of 2 is 0. Then we'll have minus. The high function is the x squared minus 3x plus 2. And the derivative of the low, that's the derivative of 7 minus x, that'll be minus 1. And in the denominator, let's not forget, we have to square the denominator, so we'll have 7 minus x quantity squared. Let's multiply out a little bit. So 7 minus x times 2x minus 3. What will that look like? Okay. First term's 14x, right? 7 times 2x. Inside terms, I will have minus 2x squared. Outside terms, I have minus 3 times 7, so minus 21. And the last terms would be negative x, negative 3, so that would be positive 3x. And then we get to distribute the negative twice because of the minus and the negative 1. They cancel each other out. So we will still have, let's see, negative and negative, that'll be plus x squared minus 3x plus 2. All of that divided by 7 minus x squared. Oh, okay, and some of these terms cancel pretty quickly. So let's look at the x squareds. I got minus 2x squared plus x squared, so that's 1 negative x squared remaining. I have a 14x plus 3x minus 3x. The plus and minus 3x's cancel. That leaves me 114x. Then for the constants, negative 21 plus 2, that's a negative 19 divided by the quantity 7 minus x squared. Part D, h of x equals 3x times the natural log of 2x cubed minus 5x plus 4, all divided by the quantity 4 minus 3x. This particular problem, we're going to have to use the quotient rule and the product rule. Let's begin. We'll write h prime of x equals, remember the quotient rule we use. We do low d high minus high d low. The low function is 4 minus 3x, and for clarity, let's write d dx of the high function 3x times the ln of 2x cubed minus 5x plus 4, and then minus the high function, which is 3x times the ln of 2x cubed minus 5x plus 4, and then we want the derivative of the low function, so we'll write d dx of 4 minus 3x. Don't forget the 4 minus 3x quantity squared in the denominator. Now, to find the derivative of 3x times the natural log of 2x cubed minus 5x plus 4, we're going to have to use the product rule. So let's use that rule. That is, the d dx of 3x times the ln of the quantity 2x cubed minus 5x plus 4 is equal to the derivative of the first. So the derivative of 3x is 3 times the second function, the natural log of the quantity 2x cubed minus 5x plus 4, plus, then we'll write the first function, which is just 3x, and then we need to multiply it to the derivative of the natural log 2x cubed minus 5x plus 4. That is 1 divided by the 2x cubed minus 5x plus 4, that's the ln differentiation rule, times the derivative of the argument. The argument was 2x cubed minus 5x plus 4, so the derivative of 2x cubed is 6x squared minus the derivative of 5x is just 5. The derivative of 4 is 0. Let's continue. So, in the h prime of x formula, we will replace the d dx of 3x ln of 2x cubed minus 5x plus 4 with the derivative we obtained using the product rule. All we're going to do is pull out the 3x ln of 2x cubed minus 5x plus 4 and replace it with the derivative we obtained. And when you do, h prime of x equals the quantity 4 minus 3x times 3 times the natural log of 2x cubed minus 5x plus 4 plus 3x times 6x squared minus 5 divided by 2x cubed minus 5x plus 4 minus 3x times the ln of 2x cubed minus 5x plus 4 times the derivative of 4 minus 3x, which is negative 3, and don't forget the denominator, 4 minus 3x, quantity squared. Example 2.1.6. Determine where the tangent line is horizontal to f of x equals x cubed divided by e to the x. In order to determine where the tangent line is horizontal, we need to find where the slope equals 0. We find the slope function, or the derivative to find the slope, and then we set that derivative function equal to 0. That gives us the horizontal. So let's find the derivative. This is going to require us to use the quotient rule, so let's do it again. High over low, and we know that the derivative of a quotient, we start with the bottom squared, so low squared, then we have low d high minus high d low. Let's compute. The derivative would be, I'll start with the low, which is e to the x squared, and then for the top part we need to write the low function, which is e to the x, multiply it to the derivative of x cubed, that would be 3, bring in the 3 of the power down, x to the power of 3 minus 1 is 2, and then minus, now we'll write the high function, which is just x cubed, and the derivative of e to the x is just e to the x. It doesn't change. Let's see, we want to set this derivative equal to 0. So I have 0 is equal to, what can we factor out that would be common in the numerator? We can factor out an e to the x. We can factor out an x squared. And that will leave on the first set of term, if you have e to the x, 3x squared, and you factor out e to the x squared, you get the constant of 3 left, minus, and then for x cubed times e to the x, you factor out an x squared, you only have one x left, e to the x over e to the x is 1, and in the denominator we still have e to the x squared. Now, one of the e to the x's in the denominator can cancel because there's one in the numerator. So we'll continue and have 0 is equal to x squared times 3 minus x divided by e to the x. In order to solve this equation, you must remember that if a fraction equals 0, only the numerator can equal 0. Why? Because if you let the denominator equal 0, then the function is undefined. So we're going to set the numerator equal to 0. 0 is equal to x squared times 3 minus x, and we will continue. Let's see, using the 0 product property, we've got 0 equals x squared, and 0 is equal to 3 minus x. So the values that we get are x can be 0 or 3. Example 2.1.7. Find the derivative of f of x equals 6x cubed plus e to the x divided by the function b of x. This is still a quotient rule problem. So I will identify the numerator, which is 6x cubed plus e to the x, as the h function, and b of x, which is left as a function, is L. Now, for the function h over L, the derivative is, and I always start with the low squared so that I don't forget the denominator, and I've got low d high minus high d low. So now let's find the derivative. We'll have f prime of x is equal to, and I'll start with the quantity, the function b of x squared. Don't want to forget that. And now let's fill in the pieces. The low is b of x times the derivative of 6x cubed plus e to the x. So 6 times, bring the 3 down, so 6 times 3 is 18, times x to the power of 3 minus 1 squared, plus the derivative of e to the x is just e to the x. Then let's do minus. We'll write the high function, 6x cubed, plus e to the x, and the derivative of the bottom, the best that we can do is just write it as b prime of x. This is a good sort of exam question. Example 2.1.8. If g of 3 equals negative 2, g prime of 3 equals negative 4, h of 3 equals 5, and h prime of 3 equals 1, and f of x equals the product of g of x times h of x, then find the derivative of f at 3. Let's begin. If we have f of x equals the product of g of x times h of x, we will use the product rule to find the derivative. So f prime of x is equal to the derivative of the first function, which would be g prime of x, times the second function, plus, and then the first function, which would just be g of x, times the derivative of the second function, which would be h prime of x. So that's step 1 in the solution process. Now we need to evaluate the derivative at 3. So we're going to have g prime of 3 times h of 3 plus g of 3 times h prime of 3. Now we can substitute values. We want to find the derivative of f at 3. G prime of 3, we are given, is negative 4. H of 3 is 5. G of 3 is negative 2, and H prime of 3 is 1. Now we have a basic arithmetic problem. Negative 4 times 5 is negative 20, and then we'll do plus. Negative 2 times 1 is negative 2, so the sum of those two negative numbers is negative 22.